Civil engineering and design. For any given project, there are three phases that the Manila Civil team may get involved in, namely, front-end engineering and design, or FEED, which deals with the conceptual designs done through engineering sketches and or FEED deliverables, detailed engineering and design, which are engineered and detailed deliverables, most often including a 3D model, and construction support. This may be through field support and or responding to RFIs or requests for information. So what are the usual scopes of work that can be done here in the Manila office for the civil team? The following scopes can be developed or can be based on process industry practices: developing drainage philosophies, developing civil design criteria, developing civil specifications for roads, paving, drainage, sewers, fencings and gates, retention or detention ponds, or topographic surveys, civil standard and non-standard details, pavement, drainage, and sewer calculations, 2D drawing deliverables, a 3D model or models, and MTOs or material takeoffs. So now let's talk about the specific tasks of a civil engineer in a project. A civil engineer's task is to prepare calculations, sheets, and or reports and layouts for the civil works of the project, such as hydraulic calculations for stormwater drainage systems, sanitary sewer pipe system sizing calculations, other underground gravity systems, which include, but are not limited to, processed sewers, oily water, contaminated or potentially contaminated chemical and wastewater sewers, ponds or basins with containment area sizing calculations, pavement thickness design calculations, finished grading elevation for paving, roads, and parking, road geometry, which includes both horizontal and vertical alignments, earthworks or cut and fill analyses based on topographic surveys, and the previously mentioned material takeoff. On the other hand, a civil designer's tasks involve the heavy use of various computer-aided design or CAD applications. Their roles are as follows: site preparation plans and surface models, road plan, profile, and model, finished grading and paving plans and model, fencing gate plans and model, demolition plans, underground piping plans or underground arrangement plans, drainage systems, basin or ponds, containment plans and model, erosion control plans, temporary facilities, and underground piping isometrics, including gravity and pressure pipes, such as potable water, plant air, and fire water. For pressure pipes that continue above ground, the usual scope limit between piping and civil is about 300 millimeters, or 1 foot above HPFS, or high point of finished surface. The Manila design team makes use of the following available tools to aid them in their design: Autodesk's Civil 3D for grading, roads, and surface models, Intergraph's S3D, Autodesk's P3D, and Aviva's E3D used to model underground structures and pipes, Autodesk's AutoTurn used to analyze roads involving vehicles for access checks, clearances, vehicle tracking, and swept path maneuvers, and Intergraph's SPR and Autodesk's Navisworks for viewing 3D models. The following illustrations are example drawing deliverables issued in various projects. Site preparation plan drawing. This drawing shows the early works and site grading of the site to be developed. Underground piping plan or underground piping arrangement. This is where all underground utilities and structures are shown. These drawings show underground pipe routing, which include information such as line numbers, sizes, and elevations, and also shows adjacent structures such as foundations, duct banks, manholes, catch basins, valve boxes, and existing utilities. Isometric drawings. These show the schematic route of the pipe in isometric views, which are usually extracted from the 3D model. This can be for a gravity system or a pressurized system. Road plan and profile. This shows the geometric design of roads, as well as their horizontal and vertical alignments. Finished grading, paving, and drainage plan. This shows the information of the finished surface. Information on this drawing includes grade breaks, low and high points, location of protruding foundations, pedestals, drainage manholes, catch basins, stormwater drainage or trenches, curb areas, building footprints, roads, etc. Fencing and gate plan. This shows the plant's perimeter boundary or boundary of a specific area inside the plant, such as the hazardous areas to keep away unauthorized personnel in the area. This drawing also shows the location of the main gate, secondary gates, and other accesses throughout the site. Here are some sample snapshots from the 3D model of a completed project by the Manila team that have been captured from either S3D or Navisworks. This is a snapshot of an elevated road model with ramps. This shows finished paving and grading. This is an underground piping model. Here are some photos from the project site. Shown here is a photo of a finished road and drainage. Shown here is a stormwater drainage trench. Shown here are retention and detention ponds, which have been constructed with the help of the Manila design team. Each of those ponds has a 300 megaliter capacity. Here are photos of underground piping that have been installed at site. And here is a photo of a catch basin, and even more piping.